All right, this is Geometry, Chapter 11, Lesson 4, Volumes of Prisms and Cylinders. So the objective for today is to find the volume of a prism and the volume of a cylinder. Let's do a screen share. Okay, so a volume is a space that a figure occupies, and it's measured in cubic units. You got to fill in those blanks. Then volume of a cube is the cube of the length of its edge, or V equals E cubed. That's your basic formula for a cube. But we're not just going to talk about cubes, we're also going to talk about other space figures. So in order to find the volume of a prism or a cylinder, it's really important that you know its height and the area of its base. And so here you can kind of see these stacks of papers. You can see that this left one has been slanted, but this right one is just right on top. And so this left one is what we call an oblique prism. It's tilted. And even when it's oblique like that, you still only need to know the base and the height. And when you look at this right one, this is called a right prism. The bases are right stacked up on top of each other. And you know the base and the height. These figures right here would actually have the exact same volume. You haven't added or subtracted any sheets of paper in between the two of them. All right, and so this is what we refer to as Cavaliere's principle. Okay, so Cavaliere's principle says that if two figures have the same height and the same cross-sectional area at every level, they have the same volume. So that's looking back at these. These both have the same height. They're just the same height, obviously. And then if you make cross sections each time, they're going to just be a sheet of paper. And each sheet of paper is the same size as every other sheet of paper in the two stacks, which is why they would have the same volume. So if you look down here at these three shapes, I've got a square-based prism, rectangular, a right square-based prism first, an oblique square-based prism second, and then a triangular prism. But if you look at this cross section, each one of them has an area of 6, and they are the same height. So by Cavaliere's principle, they would have the exact same volume, okay? And so this is kind of a big deal. There is a formula for volume. It's big B, meaning the area of the base, times the height of the prism. And so it's pretty straightforward. We're going to start with some rectangles, rectangle-based prisms. It says, what is the volume of the rectangular prisms below? Well, we look at the base as being the shape it's sitting on, so here in green. And base of a rectangle is just little b times little h. So it would just be 24 times 20. We multiply those. We get 480. Then to find the volume, we take that 480 and we multiply it by how tall the prism is, our 10, and we get the total volume to be 4,800 centimeters. Now, this is volume now, and volume is measured in cubic units, like we said on the previous page. So instead of using centimeters or centimeters squared, this is where all of a sudden we start using centimeters cubed, and we end up with our answer. What I'd like you to do now is pause the video, find the volume for that shape to the right. Okay, you can check your answer with mine. I got my base to be 15 feet cubed, multiplied by the height 4, and got a total of 60 feet cubed. You've got another one. Pause the video now. Try this one again. All right, you can check your answer with mine. I got 54 feet cubed for the total volume, and the base is 18. 18 times the height 3 gets me that 54. So not everything is a square-based prism. We have triangular prisms too. So here we're finding the volume of a triangular prism. It says, what are their volumes? Well, we know that volume is base times height. So it's big B for the base, and then we're going to take the big B times the height for the volume. So the big B, that's your triangle in this shape. So if you remember area of a triangle, see if you can write down that formula. It's 1/2 base times height. And now in a triangle, the base and the height have to make a right angle. But if you look, there's no right angles, and all of these sides are the same length, 8, 8, and 8. So what we do when this occurs, we don't have a height in there, we can draw one in. So this is that shape of the base. It's an equilateral triangle, 8, 8, and 8 on the bottom. You can draw in this altitude. What it does is it cuts that base in half, so now I have 4 and 4, and creates a right angle. At this point, you can now use the Pythagorean theorem to find the height. You would go 8 squared, that's your c, equals 4 squared plus this unknown height squared. We keep going. (48) equals h squared. We now take the square root, and h is about 6.928. Now we can use that for the height in our triangle. I go back, plug that in, 1/2. Well, my base was 8, my height was 6.928. Multiply those two numbers, and I get 27.712. So we go down, we use that in our volume formula, and we multiply by the height. Now you have to be careful. A lot of people have been messing this one up lately. They would use the altitude as the height or one of those 8s for the height. Remember that the height is the distance between the bases. The bases are turned to the side, so that height is now 10. So we're going to take that whole thing, multiply it by 10. That's the distance between the triangles, and it just moves the decimal one place. I get 277.12 inches cubed. All right, so this next triangle is a little bit easier. They do have a right angle in it. Why don't you pause the video here, check, do your volume yourself, and then check your answer with mine. All right, you can check your answers with mine. I got 150 meters cubed for my volume of my triangular prism. So what we're going to do next is we're going to move on to cylinders. Because the volume of a cylinder is the product of the area of the base and the height of the cylinder. So it's a similar formula, base times height, except when you're dealing with a cylinder, you know the base. It's a circle. So you can go replace base with pi r squared, and the height still remains the height. So it's the same exact process we were just doing, but we have a standard base formula. So we just start plugging stuff in. Volume, I like to start with the base, and then find out my volume. Just helps me keep myself from making errors. So it's pi r squared. Well, my radius is 3. I plug that in. I get 9 pi. Go plug that into my volume. I get 9 pi for my base times my height. My height is 8. I keep going, and I end up with 72 pi centimeters cubed. Now, this problem to the right is similar. This isn't your first oblique shape that you've seen. So I am going to give you a pointer that this 3 is your height and this 2 is your whole diameter. Okay? So pause the video, try that one on your own, and then check your answer with me. All right, you should end up with 3 pi meters cubed, and this is where we're going to pause the video. There is a second video about those last 3 shapes. We're going to pause it. We're going to stop it here, and you have to watch the second video for those ones.